Welcome guys to my mathematics channel, Mathematics MS Simplex. Today I'll be doing separation of variables, and this is a continuation of differential equations. Now, separation of variables involves finding the general solution and also the particular solution. Let's get into it. So the general solution, its general form is fx dy dx equal gx, where fx and gx, if you realize, is a function of x. Now, y is represented as the dependent variable and x is the independent variable. When we're doing separation of variables, we separate the y function on the left and the x function on the right. So that is why we say separation of variables, because we're basically having one set of variable on the left and another set of variable on the right. Let's look at an example. Here we have dy over dx equal 4y cubed. We have to separate this differential equation. So let's look at the solution. So if you realize the first thing, cross multiply to carry it over to the right hand side, we arrive at dy equal 4y cubed dx. Next section, we will be dividing both sides by y cubed, which is what you're seeing here. These two y cubed cancel. So what we have is dy over y cubed equal, this cancels, so we have 4 dx. Now dy over y cubed is the same thing as y to the negative 3. So you're rewriting it as y to the negative 3 dy equal 4 dx. Now we can go ahead and integrate this. Integrating this, we have y to the negative 3 dy with respect to y, we're integrating it. So we add a 1, so minus 3 plus 1 over minus 3 plus 1. We're integrating the 4 with respect to x, it becomes 4x plus c. So minus 3 plus 1, that's negative 2, minus 3 plus 1, that's negative 2. Then we have the 4x plus c, and this represents our general solution. Let's look at another example. Here we have y prime equal x e to the x squared over 2. Please note that y prime is the same thing as dy over dx. So replacing the y prime as dy over dx, now we can apply separation of variables where we carry the dx beside the x e to the x squared. And from doing this, we can go ahead and integrate. Now looking at this integral of dy, it is the same thing as the integral of 1 dy. So on this side, if you realize, we have x e to the x squared over 2. Now we are going to use the substitution method where we replace x squared over 2 to be u, and differentiating this. But before differentiating, we can rewrite x squared over 2 as a half x squared. Now, differentiating this function, we have u to be du over dx because we're differentiating u with respect to x. And differentiating half x squared, 2 times a half, that's 1. And subtract 1 from 2, I'm left with the power 1. So that's why I have an x here. And cross multiplying, so carrying the dx beside the x, so we have du equal x dx. Now, remember I said that having no value here means that there's a 1. So having the 1 inserted here. So we have the integral of 1 dy, and we did a replacement where x squared over 2 is the same thing as u. So we have e to the u, and x dx is the same thing as du. So integrating 1 with respect to y, we arrive at y, and integrating e to the u, we have e to the u. Why is that so? Because integral of e to the x is e to the x. And when you're integrating, we have to have plus the constant c. So it means that Replacing u with x squared over 2, our general solution is y equal x squared over 2 plus c. Let's look at another example where we're finding the general solution for dy over dx equals 2 sec 2y. Now first, so we carry the dx over to the equal sign, which is what we have here. Then we divide both sides by sec 2y. So divide both sides by sec 2y. These cancel. We have dy over sec 2y is the same thing as 1 over sec 2y dy. And these two sec 2y cancel, so we have 2 dx. Don't forget that sec 2y has a trig identity of 1 over cos 2y. So it also means that cos 2y is the same thing as 1 over sec 2y. So integrating this, we know that 1 over sec 2y is cos 2y. Now we can go ahead and integrate. And integrating, we have half sine 2y equal 2x plus c. Find the particular solution for the following differential equation. Y prime is the same thing as dy over dx. We can also carry the 4x over the equal sign, so we have the negative 4x. Now, by separation of variable, we carry the dx going over the equal sign, which is what we have here. Then we can go ahead and integrate. So integrating this function, which is a general solution, we have integral of y is y squared over 2, and the integral of minus 4x is negative 4x squared over 2. Just remember, there's a power of 1 on this, so we add 1, and adding 1 to the power, we also add 1 in the denominator. It's the same case at the minus 4x. The power is 1, we add 1 to get the square, and we also have the 1 plus 1 in the denominator to give us a 2. Now, that's a general solution. What about if we get the initial condition? So we're given the initial condition, and once we're given that, it's called the particular solution. We'll be replacing x to be 0 and y to be 3. We'll have y to be 3 squared over 2 and x to be 0 squared times negative 4 over 2. Now, 0 in the numerator means that the entire value for this will be 0, so that will be gone. So what we have is 3 squared over 2 to give us c, and that means c is 9 over 2. So it means that the particular solution, replacing y squared over 2 equal negative 4x squared over 2 plus c, the c now will be the 9 over 2, so replace it with 9 over 2, and that makes it a particular solution. We're going to find the particular solution for the function y prime x ln x equal y. So what are we going to do is divide both sides by x ln x, and the x ln x both cancel. So we're left with y prime equal y over x ln x. Now we need the y over the left hand side, so now we divide both sides by y. The two y's cancel, so what we're left with is y prime over y equal 1 over x ln x. So as stated that we have y prime over y equal 1 over x ln x. Now remember that y prime over y is the same thing as 1 over y prime. So y prime is the same thing as dy over dx, and 1 over x ln x is the same thing as 1 over x times ln x. Now 1 over x times 1 over ln x, we can rewrite it as 1 over x over ln x. So let me explain what's happening. So we have 1 over x times 1 over ln x is the same as 1 over x over ln x. Now we can use numbers, a half times a third, which is the same as 1 over 6. Now, if I have a half over 3, Just remember that a half times 1 over third is the same as a half over 3. So all I did was put the half in the numerator, so we have a half over 3. Now, we know that a half over 3 is the same thing as a half divided by 3. So we have multiplication sign, so we change it to multiplication sign, then we find the reciprocal of 3, so we have a third, and then multiplying, if you realize, is the same concept, which is 1 over 6. So that means that 1 over x times 1 over ln x is the same as 1 over x over ln x. So since we established that it's the same, we can go ahead and integrate. Now, the integral of f prime x over fx is ln fx plus c. Now, it's very important that you realize the derivative is in the numerator. So looking at this, we have the derivative in the top. So when we integrate 1 over y, we get ln y. The derivative of ln x is 1 over x. So to differentiate this, we are seeing the 1 over x. So that means this is ln x plus c. So this is my general solution right here. Say we're given an initial condition, y3 equal ln 81, then it means that x is 3 and y is ln 81. So replacing y to be ln 81 and x to be 3, we have ln 3 and ln 81. We can carry it over to the equal sign. So we have ln 81 minus ln 3 to give us 1.39. So it means, moving from the general solution, we have now the c, so our particle solution is ln y equal ln x plus 1.39. Don't forget, guys, subscribe to my channel, like, click, subscribe.